All right. Welcome, students. This is Office Hours for Joshua Good on Wednesday, 9/9/2015. Please feel free to ask any questions in the chat, or if you have a microphone, you may clock into the call and just ask questions. So I will be here for the next hour. Feel free to ask. Do, do, do. Alrighty. Do. Cool. Let me just edit this really quickly. All right. You can join in the chat then if you wish, or you can post on Piazza as well. I'm always happy to help there. So I'm actually going to pull up the second project, and I'm going to look over that really quickly. So if you all will just bear with me 1 second, we'll go ahead and do that. Let's see. Okay, so Ben had a good question regarding the project. And when we're looking at part 2 of the project, we're looking at a price comparison between bulbs and how long basically we're running. I think it said from 0 to 1200 hours in that 50-hour increment. So the way we're looking at this project is using print line statements and for loops, which is really important when considering how we need to implement the design as far as what they've given us. So if we look at if we go in and look at the project, okay, yeah. So if we go and look at the project, we can see that what it's asking for here is the idea of the main method handling the cost and the energy. Or it's calling, what we have is it's calling a method that's defined by the following. So we know that we have to set up a table using print line statements. And I believe through chapters 1 and 3, I don't think we've learned printf yet, but that might be helpful. I don't think we'll count off for that. And for that reason, it's actually extremely helpful to use printf and print line statements when formatting your table. So when we're looking at the table and the requirements for this, we can see that they have it formatted in such a way that you're basically going to list out the table. I would suggest the print line statement first and foremost, so that everything is organized in a nice format. And then for each succeeding line, we have how many hours the energy we're generating, the total, the energy total, and then the energy total from both the incandescent, the CFL, and the LED. So the way we're looking at when we do the project, you're obviously going to want to start off by implementing what we have. So the main method is going to call the calculate energy cost. And that method should use the formula which is described above. And returning that formula, you want to be careful because the energy cost you're going to get from the formula is going to be in cents. So when we're looking at that formula, you're going to want to convert that to hours, but the result is cents. So just make sure we're converting that to dollars. My apologies, not hours. Make sure we're converting that to dollars when you go through the conversion process and you're printing that out to the console. The second part of that, yeah, you do have to use the for loop within your main method to call this method and output the values on each line. So remember that each iteration of this loop is going to have to call a method 3 times, and it's going to be once for each type of bulb. So the best way to start out with this, if we are stuck on the second part, would be get that heading started. So I'd recommend, we obviously going to need to give it a title. Now, it's okay if you copy that down. We're not going to care if you change it or not. So for the title itself, energy and total cost comparison in dollars in parentheses. And then we also know that whatever's constant here is going to be our incandescent, CFL, and LED. So when we're looking at that, we can just list that out as a print line. Or if you want to print F, you could do the spaces for this as well. Now, what's also going to be constant, we know that the third line is going to be constant because that's nothing, that has nothing to do with the variables that we're moving with. So what we can do is just list that out, and with the dashes as well. So you could do hours, energy, and total for the incandescent, and then energy total for the CFL, and then energy total for LED. I think the only one that you have to consider the hours for, you're only listing that once because it's looking at it in hour increments. So that should be fine. Yeah, so the biggest thing with the for loop, the nice thing is they actually give you the equation, although you will have to convert that to dollars, like I said. So be careful with that conversion. The biggest thing about that is exactly how it says in the project. Reading from that line, each iteration of the for loop will call the method 3 times, so once for each type of bulb. And basically what that's going to mean is the for loop you should consider when you are doing that iteration is for the incandescent, make sure you're computing the cost of an incandescent bulb For the first time, it's going to be 0 hours. So you're going to want to contribute that in as, I don't think that's calling a parameter, but as we can see, I think you can use your constants. So the main thing here is when we want to try to eliminate those magic numbers, always use your constants when you can. It's going to make it easier for us, and it's going to make it easier for anybody who's reading your code to understand when you're running through those constants. And I think it also points you to the middle of 157 in your textbook. If you have that online, I think you might be able to pick up a free copy. If you just look for it, you might be able to find it. But yeah, in 157 in the 3rd edition, you can find an example of how to get that value returned from a method and print out if you don't remember how to do the return statements. So that's going to be your best friend in this project, who are those return statements. But sorry, I'm digressing a little bit. Actually, a little back on point, and for stopping for a second, for those of you watching, I do have the chat open. So if you do enter a message in the chat, if you go over to your Google Hangouts, if you just like hover your mouse over like the icon picture, what you can do is you can actually click up in the blue box. If you hover over that, it says chat. And you can just type in there, and I'll see exactly what you're typing in there. So if you have any specific questions, you can go ahead and type that in the sidebar, and I'll try to answer them while I'm talking about this. I wanted to get the Q&A feature working, but I couldn't, unfortunately. So, yeah. Anyway, back on point. Sorry about that. So when we're looking at that second part of the project, again, we have our class constants, and we have our for loop. And we know we're going to go through that and output those values as such. So when we're thinking about getting those values for the LED and the CFL and the incandescent, the best thing we're going to want to think about is how we're going to implement parameters each time we're running it. For 0 hours, we have a constant that's going to run once, compute the incandescent, and spit that out. And then through that same for loop, as we're calling it again, I think after, for that second time. Oh, okay, so let's see. Yeah, and then for that second time, obviously, you're going to want to do it for the 50, and then the third time for 100, all the way up into 1200 in those 50-hour increments. So when we're thinking about how we're going to implement that method for the energy cost in this case or the energy, I should say, for both the incandescent CFL and the LED being added over time incrementally, and the total it's going to cost every time converted to dollars, we want to think about how that's going to be printed. So I know I'm repeating myself. I apologize a little bit. But the best way, again, to think about that is going to be once you're going through the loop, then you're basically going to want to consider, okay, I have to calculate how many hours I have, or not hours in this case, how much energy I'm using for when I'm not using any hours, or let's say arbitrary hours in this case, and then compute based on the cost for an incandescent, how much that's going to cost me. So looking at the table, it's going to be 150. So we're going to make sure we're going to go through that loop once and print for the incandescent. And then calling that method, within the same method, you're going to want to get the energy for, at 0 hours in this case, if we're just looking at the top line, the CFL. In that case, it's going to be 250. And then calling that same method again, we're going to want to make sure that we're also printing the energy we're getting from LED. Again, for the first line, it's all going to be 0. And then for that, the total is going to be $5. Now, the key here is looking when we run the second iteration again. So you're not going to have to worry about your I variable or whatever random, or I should say it's not really random, but arbitrary variable you're using for your for loop necessarily. The biggest thing you want to worry about here is how that's calling the method through the for loop, and make sure that it's returning every time after you get through that. The best way I would think about the return statement for this, to put it kind of in simple terms, if you're going to be computing 3 things, you might want to handle the computation first before you handle anything else. So for those of you just joining here, we are talking about the second part of the project. We are on currently the computations, or not necessarily the computations, but the iteration for the for loop, and how that goes through and computes and outputs everything to the console as far as formatting. Yeah, so going back to that for loop and the method, you want to make sure that method's calling the parameter in this case for, Yeah, so as we can see, the parameter is going to be the watts, the hours, and the cents per kilowatt, which is going to be nice. So we actually have all that as constants, which will be great for us to throw in this case. So the way about you want to go about printing is line by line. If you think about it in a line by line basis, it's going to make it much easier than trying to think, well, now I have to return this individually, which is going to be on this line, and then I have to do this. Yeah, and then I have to get the one for incandescent, and the one I have to get for CFL or LED. So my best advice for that, if you're struggling on getting the computations set up correctly in the way you want them in the line, is to get them all computed first. And then after you do that, assign them to maybe like variables in this case, or get those computations in variables, and then print the variables using a print line. We know we can do this by using system.out.println, whatever your variables are, plus the next comma in this case, plus whatever, or depending on your format, depending on how many number of spaces are. When you're doing the single print line statement, make sure you're being careful not to exceed 100 characters on a line. The easiest way to avoid this is, I wish I could show you guys my camera, but it's not working for the moment. Again, the easiest way to kind of avoid this is if you're looking at your print line statement, you notice, oh crud, I'm going over 100 characters, you can always move the concatenation down to the next line. So system.out.println, open parentheses, whatever you're typing, yada yada, closing quotation mark, put a plus on the next line, and continue moving on there. And every time you're moving down every succeeding line, you can just add an extra plus, but make sure to close it off with quotation marks, because that'll always concatenate the string onto the next element. So that's the way you can think about how to print out onto the table. And you're definitely going to want to use, again, those constants. So hopefully that helps out a little bit when thinking about how you're going to lay that out. And I want to bring up something really important about testing in one sec. Yeah, so for any of you new here for testing, if you want to go ahead and open up the file, I don't know how many people are going to be there, but this is essentially looking at an expected energy cost for, I think we're looking at energy cost for, it's, if we're looking at the code correctly here, 7523.8.9. For that cost analysis test.java for our white box testing, which we'll learn about a little bit later in the semester, it's calling our method within cost analysis. It's calling calculate energy cost, and it's putting in 75 hours. It's going to be 23, or my apologies, 75 watts, 23 hours, and the cents per kilowatt in this case is going to be 8.9 cents, because that's what we're using for our energy cost. So add that 75 hours as just as an example in this case. The idea of the method is not going to read your code per se, because all those parameters are going to be different depending upon, well, I shouldn't say the parameters are going to be different. The method should be implemented in such a way that even if we were to throw in arbitrary variables and we know exactly what's supposed to come out, the output should not change. So even though 75 is not going to be a valid hours you are calculating, or something you do not need to calculate, when we run that test case and we're checking for your parameters to make sure that your method's working correctly, we should be able to get out, if we do put in the 75, 23, and 8.9, we should be able to get 0.15325 out. And whatever that cost is going to be, we're going to make sure that returns true. And if both of those are correct, then you know that you did it right for your parameter method. So that's kind of an overview of the second part of the project. Yeah, so I would just be extremely careful when using your constants. Make sure that you're converting your cents per hour to dollars per hour. So you're going to want to figure out that conversion and make sure that's what you're returning with your variables or however you're handling your print line statements. And make sure it's formatted correctly. If you look down in the implementation part of part 2 of the project, you can see that it actually does go over our system.out.printf. I don't know if you guys have covered it in class yet. I'm assuming you have, or maybe you've touched on it a little bit. And that's basically going to, the syntax for printf is a little different from what you've been using for println. It's almost identical, but not entirely the same way. So for us, it's going to be, if you look at the first example on the project description page for part 2, they have an example system.out.printf. It's going to be, in quotation marks, it's going to be %9.2f. And basically what that's saying is the percent marker basically is saying to the compiler, hey, this is a print line statement or a print format statement in this case. Listen up to what it's going to do. So you're taking the variable cluster 9.2. The f tagged onto the n as a review is going to be for double. And because there's no minus sign in front of it, it's going to right align it. So everything's going to be right aligned in every column. And then when we're using the comma, that's going to be, actually, my apologies. It's going to display cost. It's going to be 9 spaces rightward, 2 being the decimals that it's going to go out to. So it's going to go out to 2 decimal places. So yeah, my apologies, screwed that up a little bit. Cost, 9 spaces right, 2 decimal places. So you're not going to get the long number that you're going to see in the cost analysis test. So that's going to cover that for part 2. If there are any more questions regarding the project or the exercises, I will be here. I have the chat open. I'm kind of surprised nobody's using it yet. And you can go ahead and just, if you want to enter some questions into the chat, I'd be happy to answer them. Or if you want to email me at my personal email, jegood@nccu.edu. I will also be answering questions through this. After office hours, I do have this recorded on YouTube. So you can always, it's going to be at jegood is the username. You can find this on YouTube and you can listen to the office hours there. So it's always helpful kind of side video if you ever need to refresh or you get stuck in the project saying, hey, I want that. Quick note about help for the project upcoming Thursday, Friday. I know this is due for you guys on Friday. I believe it's at 3, I want to say. Let me double check on that. For me, it's 3. Okay, so actually this is due for you guys in the evening. So, yeah, so the TAs usually get slammed with a lot of people when it comes to office hours. I shouldn't say just office hours, but help in general on Friday. We will try to get to the majority of you as much as we can. We can't guarantee anything. So if I'm out doing my classes or if Alex is out doing his classes and we're kind of stuck, we'll try to get to your emails as fast as possible. Or we can't guarantee you that we're going to be able to answer everybody's questions. So just know that if you send us an email, we may not be able to get back to it as fast as you hope. Alex will be holding his office hours on Friday. He'll be more available probably than I will, but I will try to answer any questions that you guys have as often as possible. So if anybody has any questions, go ahead and post to the chat or feel free to send me an email. I will be here for the next 30-ish minutes. So, yeah. If you would like any review for the test as well, feel free to shoot me an email on that. Feel free to ask questions. I'm also open to general questions. This doesn't just mainly have to be CSC. So feel free to use the chat. For those of you who do not know where it is in Google Hangouts, if you just kind of hover over in the space where the picture box is, where you're listening to my voice, if you go up into the left-hand corner, there's a thing called chat. You can click that. There should be a chat box that groups up. It'll be the group chat for this video, and you can just type questions in there. Feel free to ask anything. It doesn't have to be CSC related mostly, but it could be tests, exercises, assignments, anything that's kind of bothering you, questions for me. Shoot, feel free. Back to my email. Another one. Excellent. So let's see. Hang on, questions. Oh, okay. Excellent, Brittany. Thank you. So Brittany's question here was, I think you're the only one in the chat right now. Parameters. Okay, so let's look at math.java for a second. If you'll give me, actually, Brittany, if you'll just give me 1 second, I'm going to finish up this email to Ben, and I'll get with you on parameters in a sec. If you look at the project, we use parameters heavily, so that's also a good place to look at it. But I'll pull up my math in a sec. That she drops off. Okay, that's fine. I'll get back to you in a sec. Okay, cool. All right, so Brittany was actually talking about parameters. So actually, I will go over that right now. And the way we want to handle parameters or thinking about parameters is when we are looking at parameters, we always want to think in terms of what the method is called. So let's say, for instance, I have a method called hi, and hi is going to take an int. And when we set that up, it's going to be public static void. In this case, it could be a void or it could be anything. Let's say we're not returning anything. This public static void hi is going to be in parentheses int, and the parameter we're just going to generalize to say no. That's going to be our number. And then when we call that parameter within the message, we can do it as such, like so. So I'm actually going to type it out into the chat. It's going to look a little messy. I'm just going to try to do as much as I can. So I'm going to type the basic setup for a parameter. We'll just call this, this will be a void method, and the public static void will be, let's just call this hi, and we'll call the number, int num, and we'll set it like so. Okay, so that's the opening for that. And then on the next line, let's say we want to call this and just print it out. So we'll just do something very simple. We're going to call this print line method. And for this, we're just going to say, let's do num plus, let's just say 1. Very, very simple. And then as always, we want to close out our methods with close curly brace. So if you look at what I just kind of posted in the chat, for those of you watching at home, the way I have it set out is when we go and look at parameters, whatever is going to be thrown into what we call as the formal parameter or the formal definition of a parameter is what's going to be spit out and used within the method. Okay, I'm going to type in the chat again. I call in my main method hi1. When I call hi1, we're going to take the number 1, which is going to be our informal parameter, wherever we choose to throw in there. And we're going to use that number for wherever number appears in our in this case, our method. So when we throw 1 into the method, we see that from the chat, if we look at our system.out.print line, it's going to read and say, oh, we're going to print the number 1 because that's our parameter, plus 1, which is going to be because of concatenation and because of math, is going to be 2. So the system is going to print 2 to the console, and it's going to stop, and it's going to return back to the main method if it had anything to return to. So something a little more complicated if we're looking at the project. Let's say we're doing calculate energy. Let's look at multiple parameters for a second. I'm just going to throw this in here. I'm not going to use the formal way of doing it, but I'm just going to throw it in like so. So it's going to be calculate energy. We're going to do int. I think the way they had it set up in the project was, let's see. Let's see. Oh, there it is. Okay. So we have it set up where it's int watts and int hours. And lastly, double, it's going to be cents per kilowatt hour. So that's what it looks like right now. When we, without that spacing on the line, obviously, because that's just the way Google formats it. But when we're looking at those formal parameters, the way we're going to throw them in when we call the method, let's say I want to call calculate energy like they do in the project. It's going to be calculate energy, and we'll say we have 75 watts over 3 hours, and it's going to be 9.8, let's say, cents per kilowatt hour. So knowing this, what the method is going to do is when it's doing its calculations, it's going to take the first parameter, which we called for our watts, and that's going to put it in wherever watts is in our formula. For the formula itself, it's going to be in, if we look at the energy cost in cents, it's going to be watts. So it's going to take the watts and put it into the first position. And the second number here is going to be our time in hours. So that's going to be times 3 hours. So that's going to go into the hours position. And then we're going to take the 9.8 because it's in our cents, and we're going to throw it into our cents per kilowatt, or cost in cents per kilowatt hour. So the nice thing about that is that using all those parameters, we don't have to worry about printing it every time or assigning it to different variables. We can just call those parameter names and set it up so that we don't have to use the numbers themselves. So when we actually go in and compute, let's just say for the product, we'll call this double because the result is going to be double. Yeah, because we're using a double, we'll just say this is a double product, and this is going to be double product set. Let's see. Yeah, it's going to be double product set. In this case, for that, it's going to be watts. If that's going to be, because we're using watts for our in, for our first part, hours multiplied by cost in cents per kilowatt, which we named as our formal parameter, cents per kilowatt hour. And then using this, it'll translate whatever informal parameters or numbers that we use for each of these parameters and calculate the cost per cents per hour. I forgot. Oops. That should be add over 1,000. My apologies. You're also going to divide that by 1,000. It's going to take those parameters from whatever you called the method header, and it's going to place those into the equation itself. So it'll take 75 times 3 times 9.8 all over 1,000, and then that'll return the cost and energy per hour. But be careful that on the project it's asking for dollars, so you will have to convert that. So that's just kind of a basic relook and review of parameters and how we still need to look at them. So Brittany, if you are watching or you're not watching, I will give this to you in depth. I will actually email you in a sec, and I will make sure you get that information. Feel free to post more questions, or apparently the chat's not working for some reason, at least as far as what I'm seeing. So feel free to just email me the questions, and I will relay them on the chat. Let's see if there's any other questions. All right, so there's one from Marianne. Okay. You can ignore my neighbors out in the hall. Okay. So Marianne just actually asked a really good question. So when we're looking at our structure diagram for part 1, what we're looking at for page 42, if you actually turn that into the textbook, I'm going to do that myself. I have my trusty textbook with me. And we actually look at page 42 in the textbook. The structure diagram Dr. Schmidt wants us to look at is the one that's down on the bottom. So what we want you guys to do, and when we did this project last year, is to really look on how your methods are connecting to each other. So if you have, in this case, you're always going to have your main method. We want to figure out what your main method's calling. So what methods are being called within the main method? And vice versa, if you have methods that are being called from other methods, what methods are being called like that? So the way you want to think about doing the structure diagrams is you're always going to start with your main method at the top, because that's never going to change. You will always have a main method. And you're obviously going to need, we're wanting to use more methods than, just one if you have repeated patterns. So, let's say if we look at the example on page 41, in the textbook we have a rocket that we're calling, and we see that we can break down the rocket using procedural decomposition into more parts than we originally had. So instead of trying to draw the entire rocket in just one massive method, or just letting the main method do it, we're going to try to outsource that. We're just going to move it into a different method that breaks it up into chunks. So for the first part, we can see in the rocket that it has a repeated triangle shape pattern twice. So we could actually break that into a method maybe like called top rocket, and we can just outprint the lines that way. And then we also see that it has a bottom and a top section that are the same with the squares and the pluses that could be used, and a middle section with the United States that could be called itself. So actually what we could do here is call 3 separate methods, which is actually what it is. And in this case, what we can end up doing is just drawing, let's say we had a main method that calls the subsequent methods, and we'll have a draw top that basically draws the top of the diamond of the ship. We can say the draw middle section, or we'll say the draw the body, and that'll be just that segment of print lines that looks like the body. And we can call the middle, or you can say in this case, because it says United States, we can call logo. And that'll print that in the middle because that's called next. And then we can go back and say call body because it's the exact same pattern at the top of the rocket. So we can go back in and through that calling of the body statement again, that line, instead of having you manually type in the print lines. And that saves us so much more time and so much more lines of code to really focus in on designing a clean and cohesive program. So it's not huge. And then finally, we can just call the top again because it's the exact same pattern that we had. So that's a way of thinking about our procedural decomposition. And then going back to that question about how we would do that in the structure diagram, would be that we have 3 different methods that are called within the main method. So our main method would be at the top. And then linking off of all that, almost think of it like a tree or like, yeah, just kind of like a tree with its limbs. The main would be the trunk. And then splitting off of that would be each of the 3 methods. So contained within the trunk in this tree would be our draw body, draw top, and our draw logo. And that would basically just cover the extension of the procedural decomposition we have for this rocket. So that answers that first question. If you're confused at all, please send me another email or just post to me about that information if you're just a little confused about that. Cool. Okay. Yeah, and then to answer the second part of that question, we're not going to ask you for that structure diagram to indicate any parameter or print line statements. It's not necessary. For this one, there really isn't any necessary need to use parameters for part 1 of the project. You could probably get away without using them. You're just using print line statements. I wouldn't worry about it too much. So that's that covers that part. Okay, part 2, let's see. Okay, so that is actually a great question. So on Marianne's question, the second part, she's saying she has a few lines of parameters that go over 100 characters. And she's basically just broken the lines at a comma, continuing to do this on the next line. Yeah, Marianne, if you are listening or if you are seeing this from, I'll email you in a second. The best way to go about that, yeah, that's perfectly fine. If you want to do it with commas or if there are commas in there, that's perfectly fine. What you can also do is what we call breaking it with string concatenation. So we know that, let's do string example in the chat. I know this won't appear in the final video, but I'll just say string example. And when we're doing our system print line statement, so system.out.println, you can see that I'm going to type the word hi, and I'll put a space. I'm going to put a plus. I'm going to put a number there. So let's say 45, for instance. I'm going to close it off and put it semicolon. So what's going to print out when we call this in the main method is going to be hi space at 45. So that's going to appear in our console because what that print line statement is doing is it's going to the system and saying, hey, this is what the user wants, and we're printing it out to the console. So imagine that we did that hi statement like a million times, and it's getting to 100 characters, and we're looking at it as like, well, now we're approaching the limit. What we can do instead is we can call system.out.println, and let's say we continue with this. Say system.out.println. Assuming we've hit 100 characters here, hi, I'm going to do dot, 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 or the ellipses here just to extend that. We've hit the characters, we say, oh, crud, we have too many. What we can do is, breaking this part of the second lines, we can go ahead and within that same print line statement on the next line, move a plus right next to where the print line statement would begin, and then throw back in your parentheses and say 45. And then obviously close it out and put the semicolon. So in this case, it'll work the same way. this way we reduce the amount of characters that are on our line and we don't go over 100. Remember that we want to keep it at a maximum of 100 characters per line. It's easier for us to keep track of your code, and industry-wise, if you're going over 100 characters, it's going to be very difficult for somebody who's either white box testing or just looking at your code in general to understand what you're doing with it. So if you're going through like a ton of different methods with like 50 different lines of code, let's say, and each of them are over 100 characters, it's going to get really messy. And those of you who are looking at the code, or somebody's looking at the code and saying, I really don't know where this is going, it's just going to get even more confusing. So we really want to try to keep it under that 100 character limit, or as close to that under as we can go. It makes it easier for us. It makes it easier for those who are looking at your code to keep track of your variables and your print line statements or whatever you're calling in your code, so that we can look at the process of your program a little easier. So I'm going to go ahead and answer that question for her, and that should be recorded here now. Keep posting your questions. These are actually really good. So I thank you. This is probably the biggest, I should say, this is the biggest Google Hangout I think we've had yet. So that's actually really nice. There we go. Just keep on sending those emails. No, I will be on here because I started a little bit late. My apologies. For the next, I want to say, when did I start? I started at like 6:10. I'm going to be on here for the next 15 or so minutes. So please go ahead. Feel free to shoot me some more questions. If you're having trouble, if you're just asking about exercises, anything at all, feel free to email me. Again, that's jegood@ncsu.edu. You can also find my email, if that didn't come out clearly, on the Moodle homepage. Actually, a quick note about office hours that I meant to hold earlier this week. It doesn't look like I will be able to make those up. I have a lot of work I got to catch up on myself. So this will be the only office hours I will be holding this week. I will try to answer, again, as many emails as I can approaching the deadline for the project. I can't guarantee you how many I can get to, but I will see what I can do to help you guys, because my schedule is a little weird on Fridays and Thursdays. But I will be around, hopefully, checking my email as much as I can to help you guys out with the project. Cool. Actually, whoever's viewing right now, go ahead and send me an email just with your name so I can keep track who's actually in here. I like to see what students are using office hours and who aren't. It's not like a attendance thing or anything. Obviously, this is optional. I just like to know who's in here so I can see who's coming and who isn't. Thank you. Any more questions? Oh, give me 1 second, Brittany. I should be able to add you to the chat. If not, I'm not. Why is that disabled? That's really weird. Is this at all? No. There's got to be a way to fix this. Yeah, I'm sorry that I can't. You can't see what I'm typing. Yeah, it's a little disappointing. I wish I could do that. Let me see if I can pull it open in here. So I'm actually going to post. There's a lot of people watching right now, right? Should be. You. Just gonna. No, that's not gonna start. Yeah. Sorry about that. I wish I could get that working. I guess it wasn't for some reason. So yeah. I could stop searching for the face. Cancel out of that. Okay. Cool. Cool. Yeah, sorry about that, Brittany. I think what I'll do is I'll send you an email regarding your question about parameters. Let me shoot you that right now, and I'll show you exactly what I was printing in the chat. I don't know why you can't see that. My apologies. Okay, so actually, to answer your original question, I will go pull up mymath.java right now, so we're on the same page. Yeah, I meant to do that in the beginning. I got a little sidetracked. So yeah, let me do that right now, and I will help you out exactly with what you had. I hope my explanation for the parameters was good, but let me try to be a little more specific. Okay, looking at that now. So let me get that open in a, on my screen, I'm going to open this up in a text editor, and I'll go ahead and take a look at that. So just close out these. We'll go downloads, and we'll take a look at my math. Cool. All right. All right, so let's take a look at the first. They want you to use return statements for this at all? No, okay, I guess they're not. It's just using parameters. So if we're looking at the values here, what we can actually use for these parameters for my math, if we're looking at this assignment, we can actually use the math class to compute these. So for the first one, if we're looking at my math min, we're taking the variables 5, 6, and 7. So we can actually use math min to compare values. And the simplest way to think about this, because we can't use if statements, which we'll learn later, what we can actually do is take the first parameter, so we put in 5, and we're going to, this basically using doubles because it's just in case we haven't double inputted where you need to handle that error exception. That's why we have doubles in there. And we can actually use math.min to compare two numbers. So whatever's smaller, that's what math.min is going to return. And then for that second one, after we determine which one of those two numbers is the smallest, we can actually go in and look at, in this case, the next two numbers. So taking that result from math.min, we can math.min that result by storing it as a variable, and then use that variable compared to the second number, and then we can get the smallest number out of those two. So that'll be kind of a surefire way to check which of those numbers is the min. So I'll actually type that in and send that as an email now for that first mark. I'm just going to send you an email right now. Cool. Okay. So you should be getting an email from me hopefully soon. Hopefully. Basically what I'm saying is the first part of math.min, because we're looking at the minimum between three numbers, is going to be taking three parameters or numbers in this case. So, the format is as follows. The public static, I believe it's the void method. Min, it's going to be int a, or I think double a, c. And double c. And then using that, what we can do is, so now we have the method. So, okay. Basically, the method's going to call the parameters wherever you place them. So if you place an A anywhere in that method, it's going to call it wherever that A is. So for example, let's say, hold on a sec, actually. So let's say for the min, we do this. Within the min, let's say we call, so for the first part, let's say we do, it's going to be math. Well, actually, we'll store it as a variable because it'll be easier. So let's say int small, or it's, in this case, it can be double small, just in case. We'll say double small. And the small is going to store the min. So we'll go math.min, and then we'll compare, let's say, A and B first. So now we know which of the two out of A and B, regardless of what parameters we have, is going to be that. And then we'll say double min to establish the actual min is going to be math dot, and then min, again, is going to be small, and our last parameter being C. So even if we don't know if A is the smallest or B is the smallest, we'll definitely know if it is once we compare whatever the smallest number out of that is to C. So regardless of what parameters you stick in those slots, it'll compare it. So in this case, if A is 5, B is 6, and C is 7, we can say that according to the method, and the A is less than B, so when calling min on, it's going to be small and say 7. A is set to small, and C is 7. So small is less than 7. And therefore, basically what small is going to equal is going to be, in this case, or min, I should say, my apologies, min is going to be small. Which is going to be, in this case, it's going to be 5. That's just kind of a general overview. Okay, so I'm sending that to you now. All right, and with that answered, I am shutting down the chat. So, Brittany, hopefully you got that. That should be there now. And I'm now closing down the Hangout. Thank you all for attending. I think this is the biggest one we've had yet and the most successful one, which I'm very happy that we had a lot of people answer. I will be online periodically throughout the night up until about 11:30 p.m. So if you still have any more questions regarding the project, please feel free to contact me in my personal email, post on Piazza, contact the support group. That is also on the Moodle page. If you need to contact that email, I can't remember it off the top of my head. Have a great night, guys, and code on. We will see your projects on Friday. Have a good one.